Hello, I am about to solve a limiting reagent problem for AP Chemistry. This problem is problem 1 from class today. I'm going to read it out loud. A fuel mixture used in the early days of rocketry consisted of two liquids, hydrazine, N2H4, and dinitrogen tetroxide, N2O4, which ignite on contact to form nitrogen gas and water vapor. Part A asks, how many grams of nitrogen gas form when 1.00 times 10 to the second grams of N2H4 and 2.00 times 10 to the second grams of N2O4 are mixed. Something to keep in mind is that this same problem could also be asked, find the limiting reagent. So, your first step is to balance the reaction. You'll see that I balanced the reaction right here. Your second step, which is the really important step that we talked about in class, is called pick a product. For pick a product, you convert from mass or moles of each given to the moles of that product you picked. In this case, I have my reactants, N2H4 and N2O4, and the product I picked was N2. So, in these two train tracks, you will see that I started out with each given, convert to moles of each given, and then my last step is to find the moles of N2, that product that I picked. In the end, I got 4.68 moles of N2 from the given, which was N2H4, and I got 6.51 moles of N2 from the given that was N2O4. Next, in step 3, that's where you identify what the limiting reagent is. We know that the limiting reagent is the reagent which makes less product. In this case, since 4.68 moles of N2 was less product than 6.51 moles of N2, you know that the limiting reagent is N2H4. Keep in mind that N2 is not the limiting reagent. Even though this is your smaller number, the limiting reagent is N2H4. It is not N2. Another way that you could think about it is, and I wrote this down, you could also think of the limiting reagent as the thing which runs out first in the reaction. So if you had N2H4 and N2O4, you're going to run out of N2H4 first. That's our pick a product method. Now, since the last step in part A needs you to find the grams of nitrogen gas, step 4 in part A is to convert from the moles of product, which you just calculated, 4.68, to the mass of the product. Now remember, we use 4.68 since that came from the limiting reagent. That's the amount of N2 which is able to be made from the two givens which we were given in the problem. From this work, I can find from moles of N2, using the molar mass, you get that 131 grams of N2 were made. This is your answer for part A. Part 2 is asking about the excess reagent. Excess reagent is the reagent that's not limiting, so it's the other one. Since N2H4 was our limiting reagent, N2O4 is the excess reagent. It's left over in the end. Let's look back at this train track method. The way we do this is we look at how much N2H4 reacted. Since this was the limiting reagent, we know that all of it reacted. So we're going to start with the given, which was the limiting reagent. For this train track, we convert from grams of N2H4 to moles of N2H4. Then we use our stoichiometric ratio from the balanced reaction. And last, we use the molar mass of N2O4. Since we just said that N2O4 is the excess reagent, we should be left with, in the end, the mass of N2O4. For that, we got 144 grams of N2O4 that reacted. In step 2 of part B, we're looking specifically for the amount that's left over. Now remember, step 1 gave us how much of the excess reacted. This will tell us how much is left over. The formula for this is the amount original minus the amount that reacted. We know that we started with 2.00 times 10 to the 2 grams of N2O4. And we just calculated that 144 grams reacted. When you solve this, and keep in mind that this is just 200, the answer is 56 grams of N2O4, which is left over in the end. I know that part C asks for a reaction table, but we're not going to use that because I think it makes it more complicated, and we're going to learn about reaction tables in acids and bases. Thank you. I hope this was helpful.